All right, so today we're doing absolute value and inequalities. We're mixing the last two lessons. So just as you did before when we had absolute value, the first thing you need to do is branch your equation and set it equal to the positive and the negative. On the first one, it's going to be x is less than k and x is, now when I'm setting it equal to the negative, it's like multiplying the statement by a negative. So I have to take the opposite. Since I'm taking the opposite k, I'm going to also have to take the opposite inequality. Since I'm making it equal to the negative k, we have to flip the inequality. For the next one, when we branch it out, we're going to get x is greater than k, or when I take the negative k, it's going to be x is less than negative k. Okay? Because we take, one more time, since I'm taking the opposite sign here, I have to flip the inequality. The opposite sign here, I have to flip the inequality. Now, you'll notice that on the first one, I used the term and. How did you guys know that, how do you think I knew that and was the correct word there? What do you think implied that? Go, what was your answer?
Whether the inequality was greater than or less than.
Okay, the direction of the inequality, and what did you say?
Whether it was less than or greater than.
Okay, same thing. So, I thought you had two different answers before.
The direction of the inequality.
Yeah.
And then
Okay, so when we have less than, I want you to think of that as an and statement. When it's a less than, it's an and statement. And we have a shortcut that we can use. We say less than, less than. And when the greater is touching the inequality, it's an or statement, and our shortcut for that one would be great or. So we know that greater than is touching the absolute value, it's an or statement. If the less than is touching, it's less than. Okay, then it reminds you to use the and. Got it? And again, when the great or is touching, it is an or statement. Great or. Okay, great or. Greater is touching here, so it's an or statement. Okay? All right, so what do I do first thing? Did we do this one yet? No. Okay, what do we do first? Let's go, Brianna. We branch out, and the first one's going to be?
X is less than 5.
X is less than 5. We write down the original inequality, and the second one's going to be, Nicole?
X is greater than negative 5.
Greater than negative 5. And what word am I using to describe it? Everybody? And, because it's less than. And we go to graph that. Right? You can write it as an in-between, or you don't have to. I don't think you need to take that time to rewrite the step. As long as you can follow the directions of the line x is less than 5 and x is greater than negative 5. So we know that less than 5 starts here, and greater than negative 5 goes here, and it's going in this direction, so we draw it like that. And we know it's an and, we know it's an intersection, because it says less than is touching. I know it's an and, I know it's an intersection, so it should have one line. Okay, you should be writing these, not listening. Writing these, not listening. Why don't you pause the recording and try the next one? Okay, Julia, what am I doing? X is greater than 5. And then what word do I use? Or. Or x is less than negative 5. And then I put them on the number line. Right? And this is an or statement. So is this an intersection or a union? Should there be one or two lines? Two. So follow the directions and see if, in fact, you get two lines. X is greater than 5. Boom. X is less than negative 5. Boom. Okay, questions? All right, so that is intersection and union. So let's add that to our notes. This is an intersection. This is a union. Got it? Intersection and union. This should have one line. Most of the time, except for the exceptions, this should have 2 lines. We always start with drawing 1 line or 2 lines, right? All right, you ready to check? To keep going on? Okay, so let's do the next one. I want you to take a minute and I want you to graph and split the next one. Go. Pause the recording. All right, so we're going to branch our first one, number 3, and we get what? X is
less than or equal to negative 2, and x is greater than or equal to 2.
okay, it's an and statement because it's less than. I'm going to follow the directions of my graph, and you will notice that we have x is less than negative 2, right? And the other one, x is greater than 2. And so I ask you, where is and or is and a union or an intersection?
And would be an intersection.
So where is the intersection here?
Nowhere.
Nowhere. So we would say no solution because there is no intersection. Okay, no solution. Now, you could have told that also from the original. If you make sense of this, we know what needs to go in here that would be less than or equal to negative 2.
Oh, you don't have to do any of it to find out it's no solution
Because there's nothing that would work.
Yeah.
Right? We said absolute value can never equal negative 2. In this case, we really have to, you really have to make sense of the situation, because any number I put in here is going to end up being positive. Is 1 less than or equal to negative 2. So there's not going to be any positive number that will be less than or equal to negative 2. So in this situation, it's a no solution. Now let's go on to the next one. Okay, so we're going to branch it again. X is greater than or equal to negative 2, or x is less than or equal to negative 2, positive 2. We take the opposite. Right? Instead of negative this time, we're setting it equal to the negative 2. So if I do that, I have to flip the inequality. Okay? And then, is this an and or an or statement? It's or because gray to or. And we're going to graph it. I'm following the directions. So in this case, it says x is greater than negative 2. I start here. I'm going in the greater than direction. And then the next one, I start here, x is less than. So what is the answer here? What? There's a solution. All of this is a solution. In this case, it's all real numbers. So the answer in this case would be all real numbers, yes. You have to look at your graph and make sense of it. Does that make sense?
Yes.
Okay. So, because the union says all the numbers in this line are part of the new set and all the numbers in this line are part of the new set. So it eventually hits every number. Okay, all real numbers. All right, so now we're solving equations. The big rule here is isolate the absolute variable, absolute value before you branch. So there's nothing to get rid of, so we just branch right away. Go. Pause the recording and you guys try it. Okay? Who wants to, how about Chloe? Why don't you tell us what to do?
So first we add 5 on both sides.
First, we branch. You got to get when the absolute values alone is the branching. Did you do it before?
Yeah.
Okay, that's a big problem. Okay, so we branch first, and it's an and statement because it's less than, and now I add 5. Go on.
We add 5 both sides.
If you solve first, then, well, let's just look. Hold on. Let's compare both. So then what would I do? I'm adding 5. I get 8. I add 5. I get -2. Whereas if I were to solve it first, x minus 5 is less than 3. Add 5, right? We go x is in here, is less than 8. Did you get x is less than plus or minus 8?
Yeah.
See what you're not getting the correct second equation.
But in our other lesson, how come we didn't switch the sign?
Last night's lesson? Because we were doing equations. It was an equal sign. So you have to branch first. I'm glad that mistake came up, especially for the recording. Because let me tell you, a ton of people are going to do that. They solve, and I'm like, why are they getting plus or minus 8? Okay, so you don't get the correct because we don't ever have time to set it equal to the -3. And that would be a completely different. And so then we go and we graph it. Our minimum is 2. Our maximum is 8. We start at 2 and we go to 8. Okay, questions? All right, next one, try it again. This time, one more time. When do we branch? When the absolute value is alone, it's the first step. Okay? Pause the recording. And it's not asking for set builder. Okay, the question is, if you graph it, do you have to put it into the braces? It's not asking for set builder notation, so you don't necessarily have to. And the graph really shows the list of all the solutions, right? So we have 3 ways to write the solution. We can write it in roster notation, we can write it in set builder notation, or we can graph it. Graphing really kind of shows how many. So we're doing 2x minus 3 is greater than 9, and 2x minus 3, it's an or statement, not an and, or because it's great or. So should this answer be 2 lines on a graph or 1? 2. So we're going to check and see if we did it right. Now, if they ask for it, I probably would still graph if they ask for set builder notation, because the graphing kind of tells me if I'm doing it right and what answer to put in that set builder. That tells me, kind of helps me with the irregularities. So I solve it and I got x is greater than 6. Did you guys get that?
Yes.
And Chloe, did you get both answers this time? Okay, so I take my minimum, is -3, my maximum, oh wait, it's an or statement, so it should be 2 lines. So I'm starting at -3 and I'm following the directions here. X is less than or equal to -3. So I'm going here and I'm going in the left direction. And then for 6, I'm starting here and it says it's greater than, and everything seems good. So if I were going to put this in set builder notation, the graph really showed it. It didn't ask me to. But if I were going to, I write x is such that, and I just write both inequalities with the or in the middle. Does that make sense? X is less than or equal to -3, or x is greater than or equal to 6. Close it up. But really only if they ask, okay? All right, so now we're making our equations a little bit more complicated. What did I say to you? When do we branch? Not get x alone, the absolute value alone. Don't touch inside the absolute value. Do we ever distribute into the absolute value? No. Never. So we always undo our addition and subtraction first. And then we undo what? Our division and multiplication. So we divide by 2 since it's being multiplied by 2. And then my absolute value is all alone, so this is the time to branch. Is this an and or an or statement?
It is an and.
Okay? Because less than is touching the. For x minus 4 is less than 8 or equal to 8. And then we're doing and. X minus 4 is greater than or equal to negative 8. And it should be one line when I go to graph it, right?
Mm-hmm.
So I'm going to take the first one is x is less than or equal to 12. Sorry, I'm going to go with the bottom one. X is greater than or equal to, so I'm going in this direction, and I see x is less than or equal to. It's an and statement, so I know to make it one line. Does everybody understand? All right, that is our PowerPoint. Questions? We're out.